but for Boeing employee. So currently we have few BD in Boeing who has basically showed their expertise in certain areas. So I'm one of them. And so my role about Boeing, basically, I'm closely working with our supply chain and supplier. So in Boeing Space and Defense, we have three divisions. We have the commercial side, we have the Boeing Space and Defense, and we have the Boeing Global Service. So I'm in the Space and Defense, and in Boeing Space and Defense, we have roughly like 12,000 supplier. So the Boeing did not build the whole plane by themselves. So we have like small supplier who basically build small part. So my role is basically to support them, work with them, help them so that they understand the engineering requirement, whatever we flow down to our supplier so that they can build the right part, right quality, right time. So my role is basically supporting them. So that's why I'm in the supply chain engineering. So I mentioned that my background aerospace engineer, almost like 10 plus years in the aerospace industry. Before joining Boeing, I used to work for Spirit Aerosystems, which is basically the biggest supplier in the aerospace industry as a senior quality engineer. And I also work as a lead manufacturing engineer at Figeac Aero North America, that is a French company. I work there as a lead manufacturing engineer. So my background in the professional career is very diverse. I work for a few company, DJ Engineering, Anton Power, LTC, some other company in different roles as a project engineer, manufacturing engineer, application engineer, also as an instructor. So my background is very diverse, but mostly in aerospace industry. So I today I will share my lessons learned, experience, and insight as an insider of the industry. So please bear with me and have an open mind. And whatever I share, it is basically based on the US or North America aerospace industry. I don't have too much experience on the Bangladesh aerospace or aviation industry. So whatever I share, it is basically based on US or North American market. So you can also see my education here. I'm from the AE1 batch of aeronautical engineering from MIST. So my journey basically start from there. So after completing my bachelor, so I applied for higher study and I got a scholarship or funding in US, one of the university in Kansas named Wichita State University. So I completed my master's in aerospace engineering from Wichita State University. And after completing my master's, I basically applied for OPT, STEM OPT. And during that period, I gained some industrial experience working some small supplier like DJ Engineering, LTC, Anton Par, all those companies. And it gives me the background. And later, I worked for Spirit Aerosystems, and now currently I'm working in Boeing. So that is basically so my journey basically start from MIST. It gives me the foundation and all the knowledge. So you can also see my credential. I will not spend too much time bragging here all these things. You can read it. I'm also a PMP certified by PMI. PMP stands for Project Management Professional. I got this certification last year. I'm also a certified quality engineer by ASQ, American Society of Quality. I have more than 20 certification in different areas. So this is basically my diversity blueprint. So when someone joined Boeing, so we need to share our blueprint. And this is exactly the same blueprint I share with my Boeing peers. So anytime a team member join, they need to share their background, their credential, previous experiences, all those things. So here on the right hand side, you can see the top picture is basically with NASA Kennedy Space Center Director Bob Cavanagh. This is basically during a competition, NASA Lunar Robotics Mining competition. So I participated along with my team member in 2013 from MIST. So on that competition, we did really well. We got like 4 award, and this one is basically one of the award. The second row, you can see the first picture is with my son here. So his name is Sabik. He want to be a Spider-Man. So when I was a kid, we always write down in our aim in life that I want to be a doctor, engineer, or something else. But when we ask him what he want to be in life, he want to be a Spider-Man. So this is his traditional pose as a Spider-Man. And then the next picture, it is basically during my master's ceremony. And the next picture is basically under the 40 under 40 award ceremony with my wife. She is also from MIST Civil Engineering Department. Currently, she is a certified professional engineer in US. So this is during that award ceremony. The third row is basically during that 40 under 40 award ceremony. So I was nominated and selected and awarded 40 under 40 awardee this year due to my achievement and contribution in the aerospace industry. And the next picture is very my favorite one. This is with my daughter. So she loves her name is Saisha. She loves her dad. So this is in one of the beach in US. And the last row is basically with one of our product, Starliner. It is in Kennedy Space Center. So you can Google what is Starliner. So this is basically one of our like spacecraft, and it is always in the news. So this is my diversity blueprint. I'll not spend too much time here. So let me go to the next slide. Okay. So I put this slide basically to provide you guys more visibility or transparency. So that's why I named the slide Connecting the Dot. So when I was an undergrad student at MIST, so I mentioned that I am from the AE1 batch. And so during that time, we don't have too much visibility, how the industry look like or what will be the prospect, whatever courses we are studying at MIST, what will be the future or how it will benefit us, so that's why I put this slide basically connecting the dot. So you can see I listed here my MIST courses here, and then potential job type or research field and what kind of skill you need to develop. So I see on the chat that a lot of you basically put that currently you guys have like A17. So I'm not sure that whatever courses I listed here, those courses are still there or not, but maybe it will give you a high level overview to connecting the dot. So you can see that during my bachelor study, level 3, level 2, level 4, we have these following courses. We have like aircraft structure and loading, we have mechanics of structure, structural vibration, aeroelasticity, computational structural analysis, mechanics of solid. So these are, so I'm from the aerospace background. During our time, we have two division. One is aerospace, another one is avionics. So most of the courses related to aerospace. So you can see all the structure courses here. And I try to basically list the potential job type or research field. If you go to academia, what kind of research field or potential job type in the aerospace industry. So this job type is directly correlated with your these courses. You can see the potential job type is basically structural analysis engineer, stress engineer, structural design engineer, composite design engineer, acoustic engineer, vibration analysis engineer, aircraft fracture and fatigue engineer, finite element analysis engineer, structure and loading engineer. So these are the actual real world engineering position. And these courses are directly related to this job type. So based on my experience, I can share that what kind of skill you need to develop so that you can obtain this kind of position on the global market. So some of the skills, so these are basically mainly like software, which is basically heavily used in this structural analysis or stress analysis field. So the first one is basically Nest and Patron. So this is basically a popular software like Boeing, Airbus, or the other OEMs. They highly use this software, and this is one of the oldest software in the structure field, Nest and Patron, Then we have the HyperWorks, HyperMesh. So Airbus heavily used this software. Then NX, CATIA, fiber sim. So fiber sim is basically for composite design or composite engineering, that is another good tool. And then Abacus, LS So all of these are tools are very very robust and strong. And all of these tool has like different workbenches. So you need to learn. So if you during your undergrad study, if you like learn maybe two or three of the software, it will definitely help in the long run. You know. Then the next type I put here, so this type is basically related to aerodynamics. So during our time, we have some courses like aerodynamics, applied aerodynamics, fluid mechanics, high-speed aerodynamics, and you can see the potential job type, what kind of opportunity you can obtain or pursue, and what kind of skill you need to develop. So the potential job type is like CFD engineer, aerodynamics engineer, automotive engineer, and skill development in US or like in North America or in Europe, like what kind of skill basically required to obtain this kind of jobs. Like these are all software also, ANSYS, Fluent Gambit, NACA airfoil simulation software. These are also highly related to this job type. The next step is related to control, control system or avionics. So you can see all the courses here. And the potential job type or field is basically, flight control engineer, control design engineer, control system engineer, GNC engineer, guidance navigation engineer, flight testing engineer, avionics engineer, aircraft system engineer. So this course is directly related to this job type or field. And not only job type, these are also research field. So if you look into academia, you can see related research field also, and what kind of software you need to, what kind of skill you need to develop to basically pursue these job roles is basically like you need to have a good, solid programming skills like Python or Java. Is anyone speaking? Uh, Mehrab, you can see me? You can hear me?
Jimmy, it's clearly we can see you and you are clearly
We
audible.
can
There
hear
must be
you.
some technical issues.
Okay. I hear a noise, that's why I want to pause. So you can see, you can relate, like, so it will give you basically a high level overview, what kind of skills you need to develop. And I think that undergrad is basically the best time to skill development, Later during my presentation, I will make some confession and I will share more insight. So, so now this world is basically based on artificial intelligence. So you need to have a solid programming skills like Python, Java, MATLAB is a good tool, Maple, all those, skills is very important. And the next step is basically related to aerospace vehicle design or aerospace propulsion. And you can see the potential job type or field. So a quick question to the audience here. So I was wondering, do you still have these courses, or it is like now you don't have these courses anymore? Anyone can respond.
Jimmy, we have these courses, this aerospace vehicle design. This is 4-1. This is conducted at 4-1, which we are having currently. And aerospace
Okay.
propulsion, it was in 3-1. So yeah, both of the
Okay.
courses are included.
So all the other top courses also there, am I correct? Like the structure or like the aerodynamics courses?
By instead of the computational structural analysis, we had actually computational fluid dynamics. So I'm
Okay.
not sure this.
CFD.
Okay.
Yeah. Okay. Makes sense. Thank you. I want to make sure. Thank you for the input. So here you can see like aerospace vehicle design, aerospace propulsion, the potential job type or research field. So you can see like aircraft design engineer, configuration engineer, structural design engineer, aerospace propulsion engineer, conceptual design engineer, and what kind of skill you need to develop. So these are all like 3D modeling software like CATIA, SolidWorks, NX, AutoCAD, So in US industry, we highly use CATIA, NX. These are the most important or popular one. Majority of the small company or big company, they use CATIA, NX, you know. So try to gain some knowledge in this software, in these skills. It will definitely help you in the long run. And then I put some additional courses here. So during our level 3 term 2, we have another course named Test and Measurement. So this course will open door for a lot of other industry, not only in aerospace. So this course basically will help you to basically open into like manufacturing, production, or quality, so quality assurance engineer, quality control engineer, supply quality, manufacturing engineer, producibility engineer, all those things. And you can also develop this skill, you know. And there are also some certification you can also obtain from American Society of Quality, CQE, Certified Quality Engineer, CQA, Certified Quality Auditor, and there are some other tools also you can learn easily, you know. Then next is machine design. You can see the potential job type or skill development. Then during our time, there was another two courses in level four. Level four, it is basically production planning and control, industrial management. And this course is basically related to like project management, program management, production manager, production planner, all those things. So this is not only in aerospace, in other industry, open door in Bangladesh also, like Walton or some other company. This one also, like you can also, if you have these skills, you can also go for any other industry, not only in aerospace. Then airfield procedure, maintenance management and repair. So it will basically, the potential job type is like airworthiness engineer, MRO engineer, repair engineer, NDT engineer, NDT specialist, all those things. And the last one is basically related to material science, mechanics of solid. And potential job type or field is basically material testing engineer, material characterization engineer, application engineer, rheology engineer, technical product specialist. So the next slide, basically, I try to categorize the scope in aerospace and aviation industry. So I got some question from Mehrab, so I try to basically create my slide based on those questions. So this one, like in Boeing or any other OEM, so we don't basically hire just only aerospace engineer. We hire all kinds of engineer. We hire aerospace engineer, we hire quality engineer, we hire industrial engineer, we hire electrical engineer, we hire mechanical structure, civil engineer. So I can give you an example. In my current role, my executive leadership, the vice president, she's from civil engineering. So any in aerospace industry, we don't hire just only aerospace. So we need all kinds of engineering, not only engineering. We need like procurement agent, we need supply chain focal, we need buyer, we need all those people. So it is not only just only aerospace engineering. And in Bangladesh, we have also some silo or misconception that if you study in aerospace, you are stuck there, you don't have any future or something like that. This is not true. This is a misconception. So if you study in aerospace engineering or avionics engineering, outside you can easily switch or you can apply for any other position in electronic engineering or computer science or structure or mechanical engineering. So here they don't look for that you graduate from aerospace engineering, so you need to apply just only for aerospace engineering. So the outside the world is very open and flexible, so you can easily switch or apply any other position. So that's why I try to group here different category. So these are actual position in Boeing. So you can see electronic or electrical engineering. So there are different roles here. Like you can see electronic and electrical system design engineer, EE technical designer, design and analysis engineer. These are all related to electronic, electrical or avionics engineering. So if you graduate from avionics, you can easily apply to these positions. And then it is another broad category in any OEM, not only in Boeing, any other OEM, Airbus, or any other company, flight engineering. So under flight engineering, we have different specialization. So one of the specialization is like GNC, guidance navigation control. Then we have propulsion engineer, we have aerodynamics engineer, we have acoustic engineer, flutter engineer, all those things, propulsion engineer. So airport engineer, so you can apply any of this position. Then the third category is basically mechanical and structural engineering. So I see a lot of question that if I graduate from aerospace, can I apply for mechanical? Or if I graduate from mechanical, can I switch to aerospace? Definitely you can. So this is the third type here. This is related to mechanical or structural engineering, like the structural analysis, stress analysis, structural and payload design engineering, then technical analysis, technical design, all those things. So like in Boeing, we have like 50 of those categories. So it is not possible to list all of them. So I try to list few of them so that you can have a real idea. So whatever you are learning during undergrad, so how it will basically help you. So always look for your passion, like whatever courses, whatever topics you like, always try to focus, gain some knowledge, more experience, learn some software, learn some new skills to those areas. It will definitely help. Then another category is basically here, the production engineering. So under production engineering, we have industrial engineering, system engineering, manufacturing engineering, tool designer, tool engineering, all those things. So it is under production engineering. So whatever courses you are like reading or like studying at MIST, it will definitely help in one of the job type or field. So I try to give a high level overview, what kind of job type or job position or research field available in US or in North America or even Europe. So far any question or any input? Okay. So there was another question from Mehrab. So he mentioned that basically about a roadmap to pursue a career in aerospace or aviation industry. So, uh, so let me make a true confession. So I'm from the AE1 batch. So in my class, I'm not always the top student. I was the average student, you know. And during my this professional life, academic career, I see a lot of like talented or smarter people than me. You know, I am not always the smartest people in the room. I see a lot of talented people than me. But what make the difference with other people and me? I try to find that and analyze that to do a self-reflect, you know, and I think about that all the time, and I this is my true confession that the difference basically is basically I was always curious. You know, if I see any new topics, I was always happy. It gives me happiness that I am going to learn something new every day, you know. So I was always curious. That is one thing. The second point is basically I never give up, you know. So uh, if I failed, I took that as an opportunity, you know, to learn something new. So every time I failed, I think that I learned something new and I will not make the same mistake again. So that is second point. So never give up. And if you fail, that is okay. Take it as an opportunity to learn and grow. So always try to bounce back. And the third point, I want to make sure that I was basically always honest with myself. I always try to give my 100%. So in life, there are some things that you can control, and there are some things you cannot control. So always focus on the things you can control. So this is basically the things make difference with other people, you know, in my life, in my experience. So I want to share with everyone so that never give up, always be honest with yourself, and always be curious. Try to learn every day, you know. So continuous learning is basically a habit. Once you find it, it will definitely help you in the long run. So that is basically my secret. So here I try to basically put a roadmap here to pursue career in aerospace or aviation in US or other foreign country. So I divide this slide into 5 phases. The first phase is basically pre-application preparation. The second one is application process. The third one is during the graduate studies in US or Canada or in other country. And the fourth phase is basically post-graduation career steps. And then the last one is basically long-term career development. So 5 phases. So I will not go through each point here, but let me give you a high-level overview. So pre-application preparation, this is basically the current phase. You guys are currently studying in MIST or like maybe graduate currently in Bangladesh. So what can you do? You know, so the first point is basically academic excellence. So a lot of people will say in your life that the CGPA does not matter. It's not true, you know, CGPA matter to qualify for, you know, to qualify for applying higher study or in any foreign university, you need to have a certain CGPA. If you don't have that CGPA, you cannot qualify to apply for any higher study institute. So the friend who told you CGPA does not matter, he's basically giving you wrong direction. So red flag. So try to maintain a good CGPA. It definitely helps. It basically make the difference with other candidates, potential candidate. The second point is basically the standardized test. So if you want to pursue higher study, or you always need to have a good score in GRE, TOEFL or IELTS. So the undergrad is best time to prepare for those things, GRE, TOEFL, IELTS, whatever country you're choosing. So you need to at least have some basic knowledge about these things during your undergrad study. So don't wait that you will finish your undergrad, then you will go for GRE, you will learn IELTS, TOEFL. Don't make the same mistake. We make that mistake. So we waste a lot of time. Like I was the cricket captain from the Usmani Hall. I used to play card all the time, watching movie. So I those are also needed, but I waste a lot of time. So now when I look back and I see that undergrad is basically best time for skill development. So utilize your time properly. The third point here is basically research universities. So identify US or other countries universities with strong aerospace, aviation, or other engineering programs. Consider different factors like faculty expertise, internship opportunities, research facilities, alumni networking, all those things. And the next point here is basically extracurricular activities. So during your undergrad study or during your this period of time, basically try to engage in relevant clubs. I see you guys are doing that actively. Try to do some publication, try to attend some competition, robotics competition, DBF, all those things, science fair. Do some project, so that you can showcase all those skills, all those experiences during your admission. Uh, you know, so all this, it definitely helps. And next point is basically financial planning. So try to explore scholarship, assistantship, financial aid options. So these are basically on the high level. I cannot, we have very limited time, so I cannot go all the point in very brief. So I try to give you a high level overview. So this is the first phase. The second phase is basically application process. So you need to apply for the university. You need to write down statement of purpose. You need to obtain some letters of recommendation from your faculty or your professors. They need to apply for the visa. This is the second phase. The third phase is basically during graduate studies in the USA. So academic focus. So you need to maintain a good CGPA here also. Then during your master's or PhD, try to obtain some internship and do some research. Networking is another important thing. So in USA, networking is very important. So, so networking can definitely help you to land in good positions, good companies. Skill development, same thing. I always focus on skill development. Try to develop some technical skills. Try to learn some CAD software, programming language, soft skills. Always try to work on your soft skills like communication skill, emotional intelligence, active listening, teamwork, all those things. Those are also very critical in US or in Canada. Then once you finish your graduate study, you can apply for OPT, STEM OPT in the US. And during that time period, you can obtain some real world experience. So it will definitely help. So this is the phase three. The fourth phase is basically post-graduation career steps. So this is you already complete your master's or PhD or postdoc from USA. What is the next step? It is basically the post-graduation career steps. So you need to look for job, employment. So target aerospace company, airlines, government agency, and defense contractor. So during that time, you need to also obtain work visa, which is called H-1B visa. You can also pursue higher education like PhD or postdoc. Then professional certifications, you can obtain some professional certifications like PMP, CQE, or any other certifications on your uh, specialization and continuous learning. always try to learn something new every day, and it definitely helps. So this is the fourth phase. And the last phase is basically long-term career development. So this one is basically networking and mentorship, learn about leadership, innovation, global opportunities. And then you can also, if you have a solid background, if you have publications or you have uh, a job that helps in US or Canada, you can basically apply for NIW, which is basically another way to obtain green card or and later your citizenship. So these are the different phases in US. So next point I put it here, which is basically challenges or risks in aerospace or aviation industry. So I put this point not to demotivate or discourage you guys, but I put this point so that you have more visibility and you are aware of the situation, you know. So one of the point in aerospace industry in Canada, it could be Canada, it could be Europe, but this is for USA. So if you want to get a job in aerospace industry or aviation industry in US, you need to have a US person. You need to become a US person or US citizenship. Most of the aerospace company here, they work for US Air Force, US Navy, or like the defense contractor. So there are some restriction or regulation in the aerospace industry, which we call like ITAR or ER restrictions. So, that's why most of the job basically require US person or US citizenship. And there are some jobs which basically require additional requirement, which is basically classified security clearances. So in Boeing, we have a program like Phantom Works or development work, which is basically recently Boeing awarded to create one of the sixth generation fighter aircraft, which is basically F-47. And to work on that program, you need to be US citizenship, not only US citizenship, you need to also have classified security clearances, so that is another challenge or risk in the aerospace industry in US. And then sometimes like when you graduate from a US university after your master's or PhD, so work authorization after post-graduation, that is another challenging. Like when you are in work visa, like H-1B or STEM OPT, to get a job into those visas, it is very challenging in the aerospace industry. So these are basically the challenges. So when you choose a career for higher study or jobs in aerospace industry, always keep this in mind. There are a lot of jobs which does not require any of them. There are some company which hire international student, but those are also very challenging. The competition is very high. You need to compete with India, China, all those peoples. So the competition is very high. So you need to develop your skills so that you can compete with them. Uh, then next point is basically the potential opportunity. I'll not go through all the point here. The last point I want to focus here, the flexibility. So I mentioned that if you graduate from aerospace or avionics from Bangladesh, so you are not stuck there. In higher study, you can apply for electrical engineering, computer science, mechanical structure, uh, in Bangladesh, we see if you graduate from mechanical, you need to work on the mechanical industry. You cannot apply for any other company. But it is not like in Europe or in Canada or in US. Your 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 world is open. So I mentioned that my vice president, she is from civil engineering. So if you graduate from aerospace, you can easily apply to mechanical engineering or electrical engineering or like avionics engineering, all those fields. So that is basically the beauty of the Western world. So you can easily switch or apply into any other position as long as you meet the basic requirement. And the basic requirement are basically you need to have a degree, 4-year degree, or you need to have a like master's degree or something like that. So they will not judge you that you come from which background. You come from aerospace, you come from avionics, you come from mechanical, you come from civil. They don't hire based on those things. They see what kind of skills you have, what kind of experience you have. Do you have the relevant experience? This is what they are looking for, and you need to always work on your soft skills. So I think this is my last slide here. So I try to give you a high level overview about the aerospace industry in US, in North America. It is very similar in Europe also. So now I'll open the floor for question answer. If you have any question answer, you can unmute yourself and you can ask me any question. Or is there any question on the chat? You can also someone help me to if there is any question on the chat. Mehrab or Najifa?
Bhai,
Sure, I think we will start the next speech and we will take the question answer at the end. Can
Okay,
you stay
sounds
with me for that long?
sure. Sounds good. Thank you. Nafi, your turn.
Ji bhai, thank you very much, Shubhecha bhai, for bearing with us and sharing this very extraordinary presentation with us. Actually, would like to conduct the question answer segment after Dr. Akhtar Mahmood Nafi bhai finishes his speech. Um,
Sure, I'm okay with that. Thank you.
uh, okay, well, thank you so much. Now, we are equally honored to welcome our second distinguished speaker, Dr. Akhtar Mahmood Nafi, former lecturer of our Aeronautical Engineering Department, now serving as an astrodynamics research scientist affiliated with the University of New Hampshire and NASA's GLIMR mission, short for Geostationary Littoral Imaging and Monitoring Radiometer. Dr. Nafi's pioneering work in orbital mechanics and space science reflects not only academic brilliance, but also a commitment to meaningful global contribution. Bhai, it is an absolute pleasure to welcome you. Please take the floor, assuming you are with us.
Yeah, thank you so much. Thank you so much for inviting me. Shubhecha bhai, thank you for your brilliant presentation. Can you, I cannot share my screen if you're sharing. So,
Shubhecha bhai, well, would you please kindly stop sharing your screen actually? Because only one person can share at a time.
Yes, I'm trying to stop sharing. Like, how can I do that? I'm new to this Zoom thing. So, okay, yeah, I got it. I got it. Thank you.
Thank you very much.
thank you, bhai. I will try to share it now. Can you see my screen?
Yes, it's clearly
Which
visible.
one? It's the presentation screen or okay, so you can see my presentation screen, right?
Yes, it's clearly visible.
Okay, thank you. Thank you so much. I want to sincerely thank the organizers first, the MIST AIAA student chapter. It's truly an honor to be invited back to speak with you all. First, I am Akhtar Mahmood Nafi. I am an astrodynamics research scientist working on NASA GLIMR mission at University of New Hampshire. I will try to go through my academic and journey in aerospace engineering so that I think it will provide a guidance for the undergrad students. So MIST is where my journey in aerospace basically began. I am from A2 batch. It's been an extraordinary journey, I can say. So after my bachelor, I joined MIST as a lecturer in aeronautical department. So every job basically uh, is solving a real life problem. As an engineer and scientist, I am fortunate enough to solve very interesting problems. I can say that. So as a lecturer, I was trying to teach undergraduate students and trying to solve their problem. And as a PhD student, and a research scientist at the university at Utah State University. I was trying to solve some astrodynamics problem. It was a really interesting astrodynamics problem. I will go to the next slide to show that. So after my PhD, I joined as an astrodynamics specialist. It was basically an internship at Keihan Space, where I basically solved problems related to spacecraft collision avoidance maneuver. After that, I joined as a postdoctoral research associate in University of New Hampshire and also in NASA Glimmer mission, which is basically a 1 year of extended interview for the next role, the astrodynamics research scientist. They gave me the position after that. From 2021, almost from the beginning of the design phase of the mission, I am working with the mission as a core or integral member of the technical staff. So now I'll go back to my PhD research. What was my motivation behind the research? So before I go there, I am from the avionics discipline, and my thesis or my interest was on the aircraft navigation, and I also published a few papers during my time at MIST. So when I was looking for PhD position, I was looking into the avionics discipline as well as spacecraft navigation sector also, because it is closer to aircraft navigation. And I found a professor was trying to hire graduate student who will track the geostationary satellite debris in geostationary orbit region. So I didn't have much idea about the debris problem, or which is like a malfunctioning satellite, the part of the satellite that exploded in the orbit. So this is a huge problem right now, because things like Starlink and other mega constellation, we need spaces inside our orbit, and they are so congested with debris objects. So it is a challenging task to remove those debris as well as catalog those. So you can see in this slide, we have a very messy orbit or very messy space around our Earth. So for the debris object or uncontrolled satellite or broken part of the satellite or rocket, those are in the smaller or like nearer orbit, we call it LEO. They will eventually come back to Earth because of the atmospheric drag. But the debris object, they are in geostationary orbit. You know, Bangladesh satellite is in geostationary orbit, and they are basically 36,000 kilometers above us. So they are very far away. So, and they are orbiting Earth, and there is no atmospheric drag there to drag them inside our atmosphere. So they will live or linger there for millions of years unless we track them and know where they are, and we put our active satellites there. So there are only two ways to track them. One is radar, using radar, and another one is optical telescope. So in my PhD, basically, we built a observatory from scratch. We designed and built the observatory from scratch. It was a high level or very expensive telescope, so that we can see a foot long of space object from Earth that is orbiting 36,000 kilometers away. So that's for that reason, we have to build that telescope 50 50-minute drive, or like around 50 kilometers away from our campus, so that there will be a less light pollution, and it's a top of a hill, and it was in the right top corner. You can see that it is in a wonderful place. There was a lake and mountain, and this is the telescope. And we use that telescope almost every night when there was no cloud in the sky, and provide the data to different organization in US Air Force, University of Texas A&M, different organization. So the drive from the campus was so beautiful, not in the winter, but it is inside, it is through the mountain. And every month, probably I have to go there twice, because something happened in the dome or in the telescope, and I have to fix that. So I was trying to solve a problem that is tracking satellite. Can we track satellite effectively with our ground-based telescope? And as I mentioned, in the winter, it was very challenging because it is top of the mountain, and we have like 4 feet of snow, and I have to work shoveling the snows, and then and I have to try to fix the telescope. So it was a great journey, and I published a few papers on that, how to effectively track geostationary debris from ground-based telescope. This is basically a part of the spacecraft navigation field. And during my PhD, I try to find a spot in the sky where there might be more debris object than other spot, based on the astrodynamics of the objects. But anyway, after my PhD, or before I go there, during my PhD, I had the opportunity to go to several AIAA conferences and attend those. And I was always a member of AIAA student chapter of Utah State University. And I published few papers there in those conferences. My favorite conference was AIAA Astrodynamics Specialist Conference, because that is in my field, and it actually moves around the whole USA every year. So I had the opportunity to travel many places because of this conference. So yeah, shout out to AIAA. I just wanted to mention that. So after finishing my PhD, I joined University of New Hampshire as a postdoctoral research associate, and started working on this NASA Glimmer mission, that is the geostationary littoral imaging and monitoring radiometer. This is a space-based instrument that will help the scientists observe and monitor ocean biology, chemistry, and ecology throughout the Gulf of USA and the different part of USA actually. So why they selected me? Because I have experience with geostationary satellite, and this is also a geostationary satellite, and it's a hundreds of millions of dollar mission, and it's not only one organization. It is a part of many organizations. They are involved in this mission. That's University of New Hampshire, NASA, Raytheon is building the instrument, then Southwest Research Institute, and other organizations. So this is basically a camera from 36,000 kilometers away, watching the ocean 24/7 from space. It's monitoring the ocean. So unfortunately, we didn't have that monitoring system till now. We have LEO satellite that monitored the ocean. But if you already know that if it's a LEO or low Earth orbit satellite, it will pass through the objects, or I can see some messages. It's not for me though. Okay. Anyway, how can I hide the chat? Let's see. Yeah, so the low Earth orbit satellites, they passes through the point, like for a certain ocean, it may have like 30 minutes every day or like 40 minutes every day, not the whole 24/7. So the mystery around the ocean, some of the like phytoplankton blooms and other rare blooms, rare species blooms, they bloom and they die over a day. So unless we have like 24/7 temporal resolution, we cannot see we cannot uh, see what's actually happening. So that's why that's the core uh, agenda of this mission, to uh, watch the ocean or monitor the ocean 24/7. So as I mentioned, it will monitor the health of the ocean, as well as it will track the harmful algal blooms if oil spills happens, and also these sargassum accumulations. So where I fit in this chemistry, biology related mission. So I am currently the team lead of this image navigation and registration portion of this mission. So this called INR, it's image navigation and registration. It is to provide the user data such that it is taken by an ideal spacecraft and ideal instrument. So ideal spacecraft is not possible because because it's a geostationary satellite, but it is not really geostationary because Earth is not a spherical true sphere. So Earth has different gravity in different parts of Earth, and it is like bulge in different areas. So because of that ununiform gravity, no spacecraft is stationary, geostationary. It will move. Its inclination will change a little bit. And also there is no ideal instrument. So where I come in, actually taking the data from the spacecraft and taking measurement from ground and give as much as accurate data to the scientist. So it's kind of tracking satellite, but in from ground, there is what I did. It's a reverse problem I'm trying to solve here. And getting perfect alignment from space is like threading a needle. It's from 36,000 kilometers away. So we have to design different estimation, like Kalman filter estimator, to process those measurement and solve this problem. So as I'm working in this mission for 4 years, and I have, so what are my some of my accomplishments are, I lead the team to pass these design reviews. So each review is like NASA's way to saying, prove your design works or start over. So first we survive the system requirement review, then preliminary design review, and then critical design review. So I remember my PhD defense. It is much more harder than those PhD defense, these reviews, because I have to defend my work where the board members are like 35 or 30 years experience of NASA engineers. So so passing those reviews definitely was my proudest moment. And as I as the design reviews passed, the mission goes on. Yeah, so those are the in like in a nutshell, these are my experience with NASA mission, and I already told about my told you about my PhD experience. So now I will take this opportunity to say if I could time travel, uh, what I would do. As most of you are from are in bachelor, doing bachelor, so from first year I will start learning Python and MATLAB. So I can say that so the work I'm doing need both the Python and MATLAB. So try to become an expert in Python and MATLAB. And I am, by the way, I am from uh, avionics side. So this is must, like Python and MATLAB. You need every work, every job will require uh, C++ or Python and MATLAB. So I'll start learning them from the beginning of the first year. And not just learning, I will I would try to be the expert in this programming language. And then the CFD, SolidWorks, and AutoCAD. So these courses are designed for bachelor or undergraduate students. I would go beyond what is in the course. Not only so these are the basics. You try to master the basic and then try to go beyond what you learn during your courses. So these curriculums are what we have in the colleges. They're they're like not what the industry currently needs. The industry is far more advanced. So I would go beyond what are in the courses, and also trying to learn machine learning, like when maybe in third year or fourth year, especially during the thesis, try to do a simple problem in part of your thesis in machine learning. So so that you will have the exposure, and also you can show that in your resume. Because most of the I'll talk about it in the future slide, but in the graduate study, currently most of the PhD students and even master students are using machine learning in their thesis, and professors are looking for the students, those who have exposure in that field. And also, you are lucky, and almost like all the students from MIST can publish their thesis. And please do that. I'm sure that you will do great on your thesis, and try to publish a paper from this thesis. So it will give you an advantage when you apply for graduate study. And also participate in a design competition like DBF or like any other robotic competition, so that you can tell that you are different from other candidates. Why I am telling that? Uh, because in my experience, or what we are talking here is the job field for US and North America. So basically, you need to have a North American degree to compete here. So in order to get a North American degree, uh, you have to have those skills in the resume to get admitted. So yeah, and I'll talk about that later also. So what are the important courses in the avionics part? I think you should uh, focus on, like, learn more than what it is in the syllabus, like numerical method. And these are the just courses, not just for credits. They are the cheat codes for solving real world problems, and I am solving those, like numerical method, uh, like integration, uh, and then trying to design all those. Like I have to design some filters that is directly related to the numerical method courses. So, and then the signal and systems. Of course, the navigation, statistics, control system engineering, C++, and C and MATLAB. So these are the most basic and important courses that you will use over and over and over again in your job. Like if it's an engineering job, then you will use those courses again and again. I cannot say enough. So uh, in those courses, try to learn as much as you can, like the interpolation technique in numerical method. So it's a cheat code for solving real life problems. Now I'll talk about the higher study. So to get a job in the US market or in the North America, you need a US degree. So to prepare for that, uh, I mentioned a few things. These are important. The CGPA, GRE, statement of purpose, recommendation letter, and publication. So every one of them is really important. If you have low CGPA, then try to get a really good mark in GRE. If you have a bad GRE score, then if you have a low GRE score, then try to, if you have a low GRE score, then try to have good publication. So it's an overall thing. It's not like if you have a bad CGPA, you cannot compete. But if you have a good CGPA, of course, you will have a better admission offer. So I will say that from my experience, the most important factor here in this 5 point is the GRE. Like if you have a good GRE score, and that you can control now, like even if you're in 4th year, you have the control over it. Maybe you have a low CGPA, you cannot do anything now. Of course, if you have 2 semesters and try to get as much as high GPA right now, but you have control over GRE. So try to get as much as possible in quant section, in math section. It's not hard. If you are admitted into MIST, then you have some good quality, and the quant section of GRE, you will do good, you do really good. And my friends and my juniors, they have done it. Like some people like got like 330 and more than 330. So it is possible. So go for it, and it will make your life really, really, really easy. So if you have a higher GRE score, then it will make your life really easy. You do not need to think about much in the other uh, uh, criteria. But if you don't get that, then you have to have a compelling package. So I think you got my point. And also, once you admitted, like you can apply for, as Shubhacha Bhai mentioned, like it's a very flexible field in the USA. Like you can go wherever you want, from electrical to aerospace, aerospace to electrical, avionics to aerospace engineering, avionics to materials, avionics to electrical. So you have the opportunity to go anywhere. But there is a catch. If you are self-funded students, you can go anywhere. But if you need funding or a scholarship, then only professor will hire you if he thinks you are useful. If he has funding for avionics related subject, then he will only hire a avionics from avionics discipline. If he has fundings in aerospace discipline or mechanical discipline, he will hire a student from that discipline, or the students that have more subject knowledge expertise on this field. So yeah, this is flexible, and you can go anywhere you like, but also depends on the university and the funding, like uh, what professor or like what type of funding the professor have and in which area of his research. So, and also from our batch, from A2 and even AE1, we have professors in the United States. So try to reach them. Like if you are fourth year student, try to reach them, try to collaborate with them, try to see who if they need any students or not. Because and I also mentioned that the funding scenario in US it is little tough right now because of this administration. The funding is little tougher, but hopefully it's enough for you to get one. Now, from my experience, as I shifted from avionics to or like aircraft navigation to spacecraft navigation, what are the uh, job prospect? So as also Shubhacheva mentioned, few of those. So the prominent one is the guidance, navigation, and control. So guidance, navigation, control covers all of the jobs. Basically, it is astrodynamics, it's a flight dynamics engineer, astrodynamics scientist, GNC engineer, control engineer. So most of the space engineering jobs related to navigation is covered by the guidance, navigation, and control. And all the space programs or the organization, they hire GNC engineer. And currently, as I mentioned, the motivation of my PhD research was for tracking and analyzing space debris. So those part of the field is now expanding. It's called space situational awareness. It's like tracking the space debris object or like space assets, and also doing generating maneuver, collision avoidance maneuver, so that if there is a collision coming to your active satellite, there is an algorithm that you can maneuver your satellite. So those are the space situational awareness jobs. And also like propulsion engineers are required, and in materials there are lots of jobs related to materials engineering. So if anyone want to pursue the space related engineering uh, in future, I think these are the four uh, prominent fields. And if you search just LinkedIn, you search guidance, navigation, control, and you will find like hundreds of jobs available. And space situational awareness, like maybe 20, 30, and propulsion and materials. Just search that, and you will find your uh, desired jobs. And also you have to before you select your like higher study topic, or uh, yeah, you should do a research in LinkedIn. You have the free tool to see what type of job you have in Glassdoor, what type of job you have. So yeah, so those are the jobs in my experience. So, and also there is one catch, as also Shubhachebai mentioned, because of this ITAR rule, the International Traffic in Arms Regulation. So most of the GNC and the propulsion jobs require the US person or US citizen. So you can see I gave some example from Aerospace Corporation, SpaceX, SpaceNet, and this is the Astroscale. So they require either a US person, that is a US green card, or US citizen. So this is a challenge every international student has to face. Like it is a little bit more tougher for aerospace background than the electrical or computer science background because they do not have these traffics and in arm regulation. So these are the challenges. But as I mentioned, it is not to demotivate you. It's like, so during your graduate study, you will publish papers. So one of the straightforward way to bypass this rule, to start like stay a few days more in academia, like do a postdoc or like find a job in academia first, and then move to the industry. And so when you will do your master's or your PhD, do that sincerely, and so that you can publish papers during that time that will have more citation, and that way you can prove yourself as a national interest, so that you can apply for national interest waiver for green card. And if you have a PhD degree, it is easier, but I saw a lot of people with master's degree also got that. So when you have those advanced degree, you can apply for NIW and you can get a green card. And then you can apply for those jobs. Yeah, so I think with this slide, I would like to conclude my presentation. If you have any question for me or Shubhacha bhai, this is the time. Thanks.
Thank you, Dr. Nafi, for your excellent presentation. Actually, would like to conduct our Q&A session now. Before we start our Q&A session, we'd just like to know, we would like to let our audience know that you can either unmute yourself and ask your questions, or you can drop your questions in the chat box. And I would also like to mention that while the Q&A session goes on, please check the chat box where we have shared a feedback form, and please do let us know your feedback in the Google form. So we'd actually start our Q&A session. In the chat box, we can see several questions already. So Imon from Aeronautical Engineering Batch 17, he wants to know, Bhaiya, what are the word for license in our job sector? I believe he wants to know the procedure to get a professional license in our job sector. So the floor is open. Anyone can answer actually.
So, Nafi, can I take this one?
Yes, by sure.
So yeah, before answering the question, thank you, Nafi. It was a very good presentation. I like your presentation, and thank you for adding more insight. We have limited time, but you touched some great point about machine learning. I forgot to add that thing. You touched some other excellent point. I think the next, the revolution or next generation, we are going basically the artificial intelligence, machine learning, deep learning. So try to gain some knowledge into machine learning, artificial intelligence. The industry is basically shifting, to that direction. So try to gain some knowledge into artificial intelligence. To answer that question, like what are work for license in job sector? So I think we need more clarification regarding this question. There are different kinds of license. It depends. Like, are you talking about in Bangladesh, or you are talking in US or any other country? So we need more clarification from Imon.
Imon, if you are with us, please kindly clarify the question which you are asking, or we just have to move on to our next question actually, because we have limited time. But he wants to know in both perspective of Bangladesh and US.
So I cannot answer on the Bangladesh perspective. I don't have enough experience to make any comment, but I can touch on the US. So in US, like we the aerospace industry, we have like different kinds of company. So the first type of company we have basically the OEMs, which is basically the original equipment manufacturer, like Boeing, then Airbus, then Beechcraft, so Lockheed Martin. So these are basically OEMs. So we basically build the original planes. So and under that, we also have different division. We have the defense side, we have the commercial side. In commercial side, we have like 737, 777, 787, 767, 747, all those things. In the defense side, we have like different fighter like F-15, F-35, F-18, F-22, all those things. So what kind of license? Are you talking about maintenance MRO license, or are you talking like any like professional competency license like project management or like quality engineering or auditor. So that question is very broad, So if you're going for like maintenance, you need to focus certain licenses from like FAA or EASA. But if you like type licenses, all those things. And I think we don't have enough background on that thing. I work for the OEMs. So here in the OEMs, we basically looking for uh, project management certification. Like I also obtained one of the certification in PMP by PMI. So that is a good certification. That is also widely recognized certification all over the world. So that is a good certification to have for project management, program management, and that is not only in aerospace. If you go to any other industry, the project management is everywhere. If you want to do anything, it always starts with project. So you need to manage some sort of project, and everything is project. In life, everything is a project. So that is a good certification to have. Then, if you go to quality, there are a lot of certification, certified quality engineer by American Society of Quality, certified quality auditor by ASQ, American Society of Quality. So then every field, like if you go to control, like if you go to electrical engineering, if you go to mechanical engineering, there are also like professional certification. It's called PE, professional certification. There are some other certification in North America or everywhere in the world. It is called EIT, Engineering and Training in North America. So a lot of jobs in US or North America, it requires this kind of certification for mechanical, electrical engineering, like PE certification, EIT certification. And if you're looking for maintenance or like MRO, maintenance repair, then I think we are not the best people to make any comment here. Nafi, you can add also.
Yeah, I think Bhai, you answered the question really well, and yes, I am also not in the field of um, aeronautics and maintenance, so I am not the right person to answer this question. But I can say that if you are talking about the licensing in the Bangladesh, in the Bangladesh sector, Bangladesh aviation sector, then like for different planes, like for Boeing, for Airbus, and different subsector, you have to take uh, earn different licensing uh, to make progress in your career. So yeah, those are very important licensing, and also in the, as Shubhachev mentioned, in the US market, like you have to get few licenses, uh, but some of them will be provided by the job or like the for like the company itself. It will give you then opportunity to take courses and get that license also. So I hope that answers part of the question.
Uh, Thank you to both of our speakers. Actually, we got a few more questions for both of our speakers. Now, we'd like to take one question for Dr. Akhtar Mahmoud Nafi Bhai, and then we'll get back to Shubhecha Bhai again. So the question for Dr. Akhtar Mahmoud Nafi Bhai is that is asking Mashinur Rahman Bhai from Aeronautical Engineering Batch 13. He says, I'm quoting him, Assalamu alaikum Nafi Bhai. I'm from Aeronautical Engineering 13 batch. Thank you for this insightful session. My major is avionics. Our current course curriculum does not cover any courses on CFD. Being an avionics majoring engineer, how crucial is it for me to learn CFD? The question is asked to Dr. Nafi. Please.
Yes, it's a good question. If I answer that from my journey, my perspective, I didn't, after graduation, I didn't have to deal with CFD at all because of my field. It is it became, after avionics engineering, it became spacecraft navigation. So I have to deal with different types of tools and different types of programming than the CFD. So it doesn't it doesn't mean that whatever you will go, like suppose you will go to a university, uh, you will get a funding from a professor that he's working on this similar area, or in that PhD program you have to take a class in that similar like a fluid dynamics and computational fluid dynamics region. So then if you learn CFD from, if you have some good idea of CFD during your undergrad, you will do really great uh, during your graduate study or PhD study or master study. But you can always learn. If current uh, curriculum doesn't provide you CFD, then try to learn that on your own time. But if you don't learn that and you are not planning to pursue a career on this CFD field, then you can skip that as well.
Thank you so much, Dr. Nafi Bhai. Actually, we'll get back to Shubhecha Bhai once again. So this
I mean, I will interrupt a bit for this question. Sorry, I'm interrupting the session. Mashanur, your query is a very important one, and we have already addressed this issue. In our recent curriculum, we have tried to give option for the avionics major to take CFD courses as well with the aerospace major students. And in future, we will try to make it a common subject. Thank you.
Thank you so much to our faculty advisor for adding an extension layer, which is very helpful for us, I believe. Now let's probably we'll switch to Shubhecha Bhai. It's a big question actually. So it's being asked from Shaiki Kahana Bhai from Mechanical Engineering Batch 18, which is equivalent to our Aeronautical Engineering 12 batch. So I'll ask the question in short because the question is actually a long one. So he says that he has great interest in flight simulator and he has already worked with Dr. Mizanur Rahman sir to make a flight simulator using MATLAB Simulink, and he usually takes different kind of fighter jets and to in weekends to get a ride in DCS, and therefore he say that he's familiar with almost all kind of weapons. So I'm quoting him at this point. I'm assuming that you worked on weapon system as well. My question is, it is nearly impossible to make a fighter from scratch in Bangladesh. However, if we want to make weapon system, as Turkey is doing and integrating them with their F-16, such as AGM 84H SLAM, ER or AGM 154C, what should be our steps in the development timeline? Last but not the least, thank you so much for providing a solid insight into the industry. Shubhecha Bhai, if you would like to.
Yes, before addressing this question, I want to also add with something with Nafi, like about the CFD thing. So maybe there are like certain courses that is not in your, like in your radar or into your curriculum. So there are a lot of like open source materials. Currently, we are living in the machine learning or artificial intelligence area, so you can learn on your own by asking like ChatGPT or like the Gemini, all those tools. It will basically teach you from scratch. And there are a lot of other platforms you can utilize, like Udemy, Coursera, and a lot of universities, they have their free courses. You can easily learn from those universities. So always try to like instead of like giving any kind of like excuses, try to explore different opportunities, different universities, free courses, and utilize the artificial intelligence, like the tools. So it will definitely help you. Okay, so coming back to this question, Ahanaf, I hope I pronounce your name correctly, but that is a very good question. So I'm glad that you have some background regarding the program you mentioned. You mentioned about FA-18. Then FA-18 is basically one of our Boeing program from Space and Defense. I also support that program. Then you mentioned about Apache. You mentioned about Chinook 46. You mentioned about F-16s. And you also basically discussed about SLAM. So yes, to answer your question, I also support the weapon system. We call it Harpoon or SLAM in Boeing. So we support different programs. So to answer your question, that the first part of the question is basically, is it nearly impossible to make a fighter from scratch in Bangladesh? So my answer, it is not nearly impossible. It is definitely possible. But to answer the second phase of the question, a lot of it is basically a puzzle. You need to solve the whole puzzle. There are a lot of like um pieces. You need to connect the dots. So the first thing to build any kind of like fighter program or anything, you need to basically develop the infrastructure. The second point, you need to have change your governmental policy, like the policy, the vision, all those things, mission, all those things. And you cannot build any fighter program from in a personal level. It need to coming from the government level, So Bangladesh Civil Aviation, the Bangladesh Air Force, lot of pieces are there. So it need to coming from the government strategy. You need to have funding, you need to develop your infrastructure, you need to train the people, you need to have a skill workforce to build any kind of fighter. A fighter is one of the like the sophisticated and sensitive program. Lot of like, lot of moving pieces. So until we have enough strategy, we have enough funding, like leadership commitment, all those things, uh, it is very difficult. So once we have all this figure out about the vision, mission, strategy, policy, all those things, and you need to collaborate with other big industry also. Once you have done those these are the pre-requirement. Once you have done those, then you can go to the next phase. So that is basically my answer on the high level. I hope it answered your question. So it depends about the development timeline. So until you fix all those things, the strategy, policy, funding, uh, it depends.
Thank you so much, Shubhecha Bhai. Do we have any more questions? If you guys have any questions, please unmute yourself and ask the question directly to our esteemed speakers, or you can drop them in our chat box. We'll take them.
And you can ask any question in Bangla also. I'm okay with any language preference, So don't feel shy.
Well, we cannot see actually any more questions coming from our audience. So I hope we can end this Q&A session, I believe. And
I see one hand up.
okay,
It's Shatik Ahnaf.
okay, Ahnaf bhai, please unmute yourself and ask the complimentary question, please.
Assalamu alaikum. My question is to Shubhetsa bhai. I couldn't ask the second question due to the word limit in chat box. My question is, I heard I was reading a news that Boeing is considering F-15 as the replacement to EA-18G Growler, as you have mentioned that you have worked with F-18C. The basic airframe is same. So is Boeing ditching one of their new programs for their battle-proven platform, or is it just a rumor? Thank you.
So that is a good question, but I cannot share any input regarding that. It is against our company policy, so I cannot share anything. So I'm here
All
today not
right.
as an Boeing employee. I'm sharing my insight as an alumni, you know.
All right, bhai. Thank you.
Thank you, Ahnaf bhai, and thank you, Shubhecha bhai, for actually taking the time and answering all the questions sincerely. And I'd also like to thank Dr. Nafi for answering all the questions with such depth and insights.
So yeah, just one concern I have is like I would like to mention before the end of the session,
Please.
as one question came up for the CFD course. So one of the most important courses that all or majority of the universities lab that have a aerospace and avionics program is orbital mechanics. So orbital mechanics is like a pathway to aeronautics to the space. So and that is the one of the most important courses, as I am saying, because it is as Bangladesh has also some satellites or like a satellite, and there is a company that hire people, hire students from, and one of my friend and senior is working there as well. So there is a uh, chance that this orbital mechanics course will help them to get a job in that domain, in that as a control guidance navigation and control engineer in the satellite company. So I think department should uh, include that course in the part of avionics or for all. So because this is in this age, it is now extremely important, and it will give MIST and aeronautical engineering student an edge over other candidate for future Bangladesh satellite company hiring. So it is my 2 cents.
So Nafi, that is a very good point. So I want to add also some few point here. So during our time there was a course named like Introduction to Space Dynamics. So is that course still available into uh, Mistian? Okay. So yeah. So another point I want to bring it here. Nafi, can you hear me?
Yes, I can hear you.
Yes. So another point. So on my concluding comment, I want to make sure that I was an average student in MIST. If I can make it, you guys can also make it. So don't be demotivated or don't be discouraged, So try to develop the skills, try to achieve more knowledge wherever you get from, So try to learn new skills and always try to improve the communication skills, all those skills, soft skills also, work on those and try to basically collaborate. Nafi mentioned a very good point. So always collaborate with your alumni, always collaborate with your, the other professor we have from our department. That is a very good point. And always looking for, always try to be curious and active. And this now the time is basically, about information. The person who have more information, he will shine. So try to basically connect, networking, and about higher study, about job. It is all about networking, and it basically depends on a complete package. So Nafi mentioned about SOP, recommendation letter, in US, which does not require GRE, and Europe, it does not IELTS, TOEFL. Try to learn new software, try to develop your skills, it will definitely help. So this is basically my commenting statement. So back to you, Alamin.
Thank you so much, Shubhecha Bhai, actually. Mashanur Bhai in the chat box also added that our space engineering course covers some of the materials of orbital mechanics like Hoffman transfer and orbital maneuvering and all these things. So yeah, thank you, Mashanur Bhai. And I hope our speakers have already got this points, as I can see. So our floor is still open, actually. If anyone wants to ask any kind of question, or if anyone wants to add any points or complementary questions, you are welcome. And if there are no more questions or points, I'd like to conclude our question answer part. And we are actually very pleased to inform all of you that we are joined by Group Captain Toibur Rahman sir. Sir is here with us, and actually, before we proceed, someone actually asked a question in the chat box, and I think it would be very good if we can take the question. I believe they have some expectation from our speakers. So someone's saying that, I'm quoting him, Assalamu alaikum, without any publication having 310 plus GRE score, IELTS 6.5 or 7, CGPA 3.22, job experience in any sector except aerospace field, is it possible for getting fully funded scholarship in USA? I'd like to ask our esteemed speakers to take on these questions.
Yes, it is definitely, so I think it is a very good profile. So I mentioned, I think I already answered that part. Like, so it is not only just only a single parameter. It is not only GRE, it is not only IELTS or CGPA. It depends on the whole package, whole profile. So you need to have a basically a, like the standard profile. You need to have a good CGPA, good IELTS, good GRE score, relevant experience. And it also some other criteria. You need to reach out to professor, you need to reach out to universities, looking for opportunities, networking, try to, Nafi mentioned a good point, LinkedIn or some other sources. So try to connect professor or other member through LinkedIn or any other platform so that you can collaborate. So it is basically a complete package. So if you that whatever you mention here, that is a good profile. So to qualify for any US university, the minimum requirement is CGPA 3. If you if your CGPA is above 3, I think you can apply any university. But to get the admission and getting the funding, two different things. So the scholarship or funding, it depends on the networking, how you reach out to your professor about your recommendation, SOP, GRE, LTS. So they're looking for the whole profile and your relevant experiences, relevant project or relevant publications. That's why we always give a lot of emphasis on the publication, do relevant experience, and try to another mistake I think Bangladeshi people or Bangladeshi students did that when they come outside, they basically looking for the funding instead of about their expertise or about their patient. So I also make the same mistakes. So when I come to USA, I was always looking for the funding instead of like what is my expertise, what is my what topics I like most. Instead of doing that, try to basically identify what is your strong area, what you have, like the passion for, and then seek out. I think Nafi did this thing. He has some specialization, some favorite topics, and he reach out to those specific professor. And on the long run, it will definitely help you. Nafi, you can also add.
Thank you, Bhai. I think you answered the question really well. So I would like to add few things. So the profile here, it's a good profile. You mentioned 310, 3.22 CGPA. So it's a good profile for it's not any stellar profile. So it is not guaranteed that you will get funding in you will get admission. So you have to work now. So if you already have this profile, it's good. Now you have to check which professor you would like to work for. So suppose like there are hundreds of US university, you will select the professors you like who is working on the same field. Try to reach out to them. So one of the way to see if those professors has funding or not, to go to their website and see if they have recently got any funding. If they have any funding, then it is very promising that he will hire a PhD student or master student. So the preparation portion is done. Now you have to go and look for the programs and the labs you would like to work, and then make a list and select the universities, like some top universities, some middle, some lower. We call it safe universities like the lower rank, and then the middle universities and the higher universities. So don't only apply for the lower rank universities, don't only apply for the higher rank universities. Apply all these three tiers. You might get into a really good university with this profile, and you may be rejected from a very lower ranked university with this profile, with the same profile. So it is not 100% guaranteed, but you have a promising start. And if I were you, then I will start making the list of the professors. It would be in like 1,000 professors with hundreds of universities, and then go to their lab and select which topics you would like to discover, or like you would like to work on in future, and then send them an email like saying you are interested to work on this topic and in his lab. Yeah, so go ahead and do that. That's another hard part, and you have to give some time. So that's my suggestion for you.
Thank you so much, Dr. Nafi Bhai. Actually, we are getting a few more questions in the chat box this time. So would like to take those questions because we believe that the questions are what is complementing this whole session. And these questions are the things that for which we arrange this program. So Abu Hena from Aeronautical Engineering 15 is asking to Shubhecha Bhai. So we will get back to Shubhecha Bhai once again. He's asking, Assalamu alaikum, Shubhecha Bhai. During your undergrad, outside your academic studies, did you self-study a lot, which gave you an edge to evaluate how significant it is when pursuing MS or PhD level? Shubhecha Bhai, if you like to.
Yeah, that is an interesting question. So I mentioned during my average student, so my CGPA was average. But there are some things I did different than other people. Like, so I was part of the NASA Lunar Robotics team. So me along with my junior, we went to NASA Kennedy Space Center. We built our robot and took that robot into NASA. We participate competition. We during our third year or fourth year. So we also built a UAV. With my roommates. My roommate at Osmania Hall was 420. Me, my three other roommate, Anwar, Ivan and Papon. So they are also doing excellent in their own field. So we built the first MIST UAV. So we did some project. I attended some competition. We do lot of STEM activity. So it definitely helps me. And during that time, I also do some publications also with my professor. So these are the things, like I did differently, and later I have a good GRE score, then a good statement of work, I got some good recommendation letter. So it is all about complete package. And then the last step is basically if you have everything and then you don't have any funding, then it is another challenge. So I reach out to a lot of professor, as Nafi mentioned. So I try to find the professor who has funding, and there are a lot of secrets also how to get funding from different professor. So I try to find the professor, and it's not bragging. I am the first student from the A department who came to outside for higher study. So uh, so basically I manage professor, and I try to find the source of funding, and then when I got the funding, and then I came to USA to do my master's. So these are the things: participate in competitions, do some project, do some publications, so it definitely helps.
Thank you so much, Shubhecha Bhai. I believe Abu Hena has got his answer. Actually, we'll take one more question. Is anyone trying to say anything? Well, so we have. If you guys are not asking anything, please unmute, mute your mic, because it will disrupt others. So it will be our last question actually. Okay. So the last question is asking Mr. Afjal, I'm quoting, Assalamu alaikum. If someone's GPA is less than 3, would GRE quant or high score cover that? So I'd like to ask both of our speakers to take on that question.
So that question is basically very tricky. So it depends. My answer is it depends. So I see a lot of exceptional cases. So in US or Canada, like that, there is a requirement that to qualify for applying for admission, you need to have a minimum CGPA of 3. But I also see some exceptional cases. They manage professor or uh, uh, where their CGPA was below 3. So it depends. So there is no hardcore rule, but to get admitted into any university outside Bangladesh, you need to have a minimum CGPA of 3. But it depends. It may or may not. So that's why, Nafi, feel free to add anything.
Yeah, I think exactly same. It is a tricky question. If it is less than 3, then it becomes very difficult. Because why a professor will hire someone? Because this CGPA, it represent actually like how consistent you are, if you are given a job to study, and how consistent you are, and it shows in your CGPA. So a professor is actually looking for a student who will work for him, and he will look for a consistent lab consistent student who will work in his lab consistently, and he will provide a good result. So yeah, so if the CGPA is low, then professor will not trust that student to hire him. Having said that, I see a lot of like cases that people with less than 3 getting the admission at the US universities, and uh, getting funding. So probably getting funding will be difficult, but maybe admission will be little easier. Maybe they will not provide funding for the first year, but after that he has to manage the funding. So there are few scenarios here, and I see, because I have a lot of experience with a lot of my friends, a lot of my juniors. So I see them. If sometimes people go to different country than USA, and then from there move to USA with this profile. So yeah, so this is possible definitely. And I mentioned that if you have one lower score, try to get as much as you can. And even with the perfect score, a good university can reject you. With all these 4 departments, you have the stellar CGPA, stellar GRE, and good IELTS, and good publication. Even that, a university can reject you because they do not have any funding, or they want uh, different fields, the students from different field, or they want more. They want students that have more extracurricular activities. So you never know what they are looking for, but there is a standard, as Shubhanshu mentioned. It's usually 3, and I was in the committee of selecting graduate students in my previous university, and see that they are very strict in what their minimum requirement is. But of course, there are exceptional cases. I would suggest that if you do not have control over your CGPA right now, you have control over all the other department, like getting a stellar GRE score and do excellent research. You do not have any other uh, option. So publish few papers and do some research. Try to collaborate with professors. Say that I will do work for you freely, and get some project done. Try to collaborate with our alumni who are the professors. They will give you probably projects to work on, and so that your CV will be much more attractive. Thank you.
Thank you so much, Dr. Nafi Bhai. Actually, that is the end of our question answer session. And now would like to proceed. So would like to welcome our very last speaker. So I'd like to invite Group Captain Toyibur Rahman sir to share some valuable words with us. If Group Captain Toyibur Rahman sir is with us, kindly unmute and please share your valuable words with us.
Assalamu alaikum. Can you hear me?
Yes, sir, you are audible, loud and clear.
Okay. First of all, I would like to express my heartfelt thanks and gratitude to the speakers, Shubhecha and Nafi. So let me just briefly tell you about me. I'm Group Captain Dr. Toyibur. So basically, I was a graduate from IUT. And then I did my master's and PhD from Beijing University of Aeronautics and Astronautics. Probably Shubhecha and Nafi, you know Saifur Rahman Bakaul.
Yes. Yes, sir.
So we are very close. He's just my immediate senior, and we are in the same university at the same
Oh, great.
PhD. And
Great.
before I joined here, I was in Aviation University as chairman, avionics engineering, and Dr. Bakaul is the current chairman, aerospace in Aviation University. However, I wanted to thank you, but before I go into giving you thanks, I touch upon three questions that the three students asked. The first question about the licensing. So you guys have answered all the question very nicely. However, for the our students who asked the question, probably he said both Bangladesh and US. And you have touched upon actually Bangladesh. I mean, probably he was asking that if you want to work as an maintenance engineer, aircraft maintenance engineer, so what are the licensing requirement? So that's, you said that's part 145, EASA licensing or FAA licensing. So those you need. Imam. The second question about the fighter project development for Bangladesh. It is a dream. Every Air Force officer dreamed that. And I don't know for which generation it will come into reality. But the speaker has rightly said that it depends on many things. First of all, your national policy, strategy, your defense policy, strategy, your requirement, your economy. So like India, Pakistan, Turkey, or Iran, the way they progress their defense industry, we cannot do that. Probably there are many barriers. The first is the national strategy and policy. So we have to first, review our national strategy and policy, and then we can develop our workforce, skilled workforce. It's not like 1, 2, or 5. And then again, an aviation industry or fighter or aircraft industry, it's not alone. There are thousands of components. So you need number of companies. Maybe everything is not possible in one country. If we talk about Eurofighter, it's a project of 4 countries, where initially France were there, but they came out and they developed the Rafale. As an Air Force member, I had the opportunity to evaluate both the aircraft physically in Eurofighter company, Leonardo, and also the Dassault Aviation, including the avionics sites, engine sites, Safran, Thales, all those. So basically, first of all, the national strategy will lead you. And if we all dream together, inshallah, one day this dream will come true. The third question was, I think, about the CFD, or there are few requirements. Yes, it is not possible to include everything in the curriculum because we have the time limitation, credit limitation. However, for your personal development, you need to study and develop your skill that your alumnus have already explained. what to do. About applying for higher study or pursuing higher study, the first criteria is that both the speakers said you have to look for the professors of your interest, or you have to align your interest with the professor's interest. That's very important. And you apply. You prepare yourself and then apply. Inshallah, you will find good. However, I don't want to prolong this session. So, on behalf of the Department of Aeronautical Engineering, MIST, I extend our heartfelt gratitude to each one of you for your active participation in the webinar on career in aviation and aerospace industries. I must appreciate the
Sir, suddenly you are not audible, sir.
organizers who made this event a success through their expertise and dedication. Let us continue to strive for excellence and innovation in our journey as future leaders in aerospace industries. To inform you that from the beginning till now, the whole session I was present, I was listening the speakers, I was listening the students' questions, and I really appreciate every one of you. Thank you very much. Shubhecha and Nafi, whenever you come to Bangladesh, try to visit your place. It is your place. We are guests. Thank you very much. Once again,
Thank you. Thank you, sir, for the good summarization. I really like answer of your question. And really, definitely, when we'll be in Bangladesh, we'll keep in touch and we'll visit our beloved department. And thank you for the opportunity sharing our thought and insight with the students.
Thank you so much.
Thank you, sir. Yeah, go ahead. Yeah, I just like to say thank you, sir, for your nice comments. And yeah, every time I go to Bangladesh and I try to visit MIST, yeah, it's been an honor for me to talk to this webinar. It was a great webinar hosted by this organization. I hope they will do great in.
Thank you both. Thank you to both of our speakers, and special thanks to Group Captain Toibur Rahman sir for taking out his valuable time and joining us in these late hours and being present for the whole time. Actually, I believe that his added layers beautifies and complements our webinar further. So, thank you all. Now we are at the very end of our session. So in this segment, we'd like to showcase some our appreciation to our esteemed speakers. So as a token of our heartfelt appreciation, we would now like to showcase the certificates of appreciation on the screen for our two guest speakers in recognition of their valuable time and inspiring contributions to this webinar. And I'd also like to request our speakers to open their camera so that we can take a picture with this certificate actually. So this one's for Shubhecha Bhai. Shubhecha Bhai, if you can kindly open your camera. I believe it's been done. Now let's move on to our next. This one's for Akhtar Mahmood Nafi Bhai. Bhai, please kindly open your camera. Thank you so much. I believe it's been done. Well, as we draw the curtain of today's webinar, I would like to extend our sincere thanks to our distinguished speakers for sharing their wisdom and real-world experiences, our respected faculty advisor and Group Captain Toibur Rahman sir for their invaluable support, our student chair and organizing committee for their tireless efforts, and most importantly, you, our participants, for being the heart of this event. Before we officially end, would like to capture this wonderful moment together. So we kindly request everyone to turn on your camera for a quick group photo. Let's take a snapshot of this shared experience. Please kindly open, everyone, please kindly open your camera. A lot of you haven't opened your camera yet. Would like to wait 30 more seconds and then we'll conclude today's session.
And Alamin, before leaving, I want to also say something. So thank you everyone for the participation. And if you need any further guidance or any kind of, if you have any question, you can reach out to me directly on my LinkedIn, or Mehrab has my contact, so you can reach out to me directly if you have need further guidance or any direction, or if you have any question. Thank you.
Thank you, Shubhechha Bhai. Would also like to drop our official Facebook page link in that comment section. You can reach out in that as well. Just give us 2 seconds. Well, we have already dropped our official Facebook page link in the comment section. I believe all our audiences will reach out to us if needed. With that being said, would like to conclude our today's session. Well, this webinar on career in aerospace and aviation industries was more than just a webinar and session. It was a journey into the future we all dream to be a part of. Stay inspired, stay curious, and as always, keep reaching for the skies. Thank you all our speakers, all our audiences, and our faculties and our faculty student chairs. Would like to conclude our today's webinar here. Allah Hafiz and a good day.
Thank you.
Thank you.
Thank you, everyone.